So, hello and welcome. My name is Marc Greenberg. I'm Product Marketing Group Director at Cadence. I'm responsible for the DDR, the HBM, the storage, and the MIPI interfaces. And today's presentation will be about hyperscaler data and the high-speed memory interfaces for next-generation chips. And this is, of course, a part of Semiconductor 360 Live 2021, and I'll be available for the Q&A session later on in the conference. So let's get going. Okay, so I want to look at, first of all, some of the considerations for hyperscaler memory interfaces. And the thing here is, as we've worked with a lot of the hyperscaler customers, is that there's actually no one single application that makes a lot of sense for hyperscaler memories. There is different applications in this space, and so there's a number of different memory technologies that may be possible to be used in the hyperscaler case. So the first one that people a lot of times will think of is just using on-die memory, right? Using cache or SRAM or maybe some embedded DRAM, whatever it may be, putting it on the CPU die. It's a great way to use memory. It's very, very fast and it's very low energy, but you can't have a lot of it. You're limited to a certain number of megabytes of data within those caches. They can't get as large as adding multiple extra dies of RAM that you could do with external DRAM. So in most cases, you're going to be limited both by the capacity as well as the cost of on-die RAM, and it's going to force you into moving that RAM into off-chip things like DDR5, LPDDR5, HBM, or GDDR6. So the rest of the conversation here today will be talking about these off-die RAMs that people will use in hyperscaler type applications. So the next memory that most people would think of would be to think of using DDR5, as you might find, in a next generation server, one-day workstation. And the DDR5 memory, as well as its low power counterpart, the LPDDR5, those are both low cost and they may be high capacity. They have some differences between them in terms of how they operate and what capacity can be achieved. The DDR5 is the best way to achieve a large capacity, and the LPDDR5 has more flexibility in some ways with a lot of different package options and being able to get to higher speeds and lower capacity configurations. So, those are great memories, and those would probably be the first things that people would think of in this space. And then there's a couple other choices as well. So we can look at the HBM memories, which, current generation is HBM2. Next generation will be HBM3. Those are extremely fast memories, and they're also relatively low energy, but they can be expensive. And so, people have to consider, the cost of those things. They're definitely winners if your metric is, gigabits per second per watt. They do great on that metric compared to the other memories. But if your metric has a per dollar in it, you may not find that you may find that it's maybe not the best memory on a per dollar basis. So that's something to consider as well. And then the last one, which I'll talk about, is lesser known. It's using the graphics memories like GDDR6, and we're seeing this starting to get used in a lot of different applications. I'll talk about that a little bit later. But the unique thing that GDDR6 does is it can provide a really good mix of a good ratio of bandwidth to capacity that other types of memory can't really offer. And I'll show that in the upcoming slides. So this is a quick summary of what I just said. This will be here so you can refer back to it or freeze the screen later if you want to look at it. But in summary, there's no perfect memory for hyperscaler. It's really going to depend on what you're trying to do. And on-die memories, again, great, but expensive, limited in capacity, and high cost per bit. DDR5s and LPDDR5s, slower, but lower cost per bit, and they can give you a huge amount of capacity if you need it. GDDR6 is kind of a middle memory in amongst all of the other ones. And then HBM3 is a very fast memory with low energy, but also the cost per bit can be relatively high. So, and then some of you may be surprised to hear me talking about LPDDR5 in a hyperscaler type context, but we are actually seeing that, and this comes partly from being somewhat historical. If we look back in the past to the DDR1, DDR2, DDR3 generations, the separation between the DDR memories and the low power memories, the LPDDR memories, there was really a big separation between them, and we saw very, very little overlap between those memory technologies. Starting at DDR4 and the LPDDR4 generation, they started to become kind of closer together in terms of what things can be achieved by those memories. And then in the DDR5, LPDDR5 generation, we're finding that there's definitely applications that want to use both DDR5 and LPDDR5 from the same SoC, but maybe with a different PCB to address different markets and different usages of the same SoC. So we are starting to see LPDDR5 even in some server type, hyperscaler type applications. And I wanted to put up another chart here, just matching the applications to the DRAM types. Again, here this is a kind of a high-level overview, but some of the things I want to indicate what we're seeing here is some new usages of memory. So LPDDR5 making its way into high-performance computing and AI applications within the hyperscaler space, and then GDDR6 starting to come in a few different places, as well as eventually the migration over to HBM3. And again, this chart, feel free to pause or screenshot this for later reference. So if you'll forgive me for a moment to talk about the Cadence offering in this space, what do we offer and what can we provide? Well, Cadence is the only provider that's providing the broadest portfolio of different memory technologies, including support for the DDR, the LPDDR, the GDDR6, and the HBM memory. So we have capabilities in all of those areas. We offer very highly configurable IP with multi-port support, and then in hyperscaler space, supporting the latest generation ARM-based buses like Chi-C and D&E, with D&E being on the roadmap. So supporting those processor buses that go with the very latest of CPUs from ARM. We have a memory VIP franchise here, business that is extremely popular. A huge number of customers using that memory VIP, and we offer also transaction level models to be able to model the IP, as well as solutions for our Palladium and Protium emulation and prototyping solutions, and FPGA models. Basically, a complete portfolio of both the IP and the things that go around the IP to be able to make a whole system and make a successful whole system. For silicon validation, we have a unique system here. It's our rapid bring up and remote debug software. This is something that runs on the bench where you're doing your bring up and debug. It connects in through a JTAG port, or it can go in through the debugger of your chip, and it runs on a separate laptop. And this software then you can share the screen of the laptop with Cadence through any type of video conferencing application. And so that allows our support engineers, even our headquarters support engineers, to get immediate access to support and help with the design and bring up of a chip. And that's something that's been really critically important, of course, in the last year with travel and things like that being very limited. So in the system delivery here for the IP, there's a few different things. The controllers for this are delivered soft, as you might expect. The DDR5s, we have two different methods of delivering DDR5s. So the first one is what we call firm PHY. This is where the most difficult to close parts of the design are delivered as GDS. And so those are the analog circuits and some of the critical training circuits. Those are delivered together as a hard block. And then the hard PHY solution is a complete GDS2 of the entire PHY delivered all together as a hard block. And we can give you your choice of which of those things that you prefer as part of the design process. The controller IP for this is a very high performance controller. We have a high performance architecture that we've been developing for many, many years. We started this back in the early 2000s, and we've been delivering controllers for DDR all that whole time, as well as GDDR and HBM more recently. It's a high performance architecture supporting all the latest memory types. We support the necessary gearing to support the higher speeds of LPDDR5 and GDDR6. And it's a high efficiency, especially with variable different traffic loads, something that we manage within the algorithms within the controller. It has a huge number of RAS features in there. So failures are very, very well controlled and detectable and correctable in many different ways using the RAS features, which are in the controller IP. And we have hundreds of customer successes using this controller IP over an extremely long period of time. So again, multi-protocol support for this. It is either AXI based. You can use the ARM AMBA Chai buses, or there's a native interface that you can use as well. It's enabled for low power using the low power modes of the different memories that may be connected, and of course, fully verified using all the Cadence verification tools. So coming back to the PHY delivery options here, I want to show graphically the firm PHY option. And as I mentioned before, what we'll deliver here is what we call a slice-based PHY, where the green boxes here represent the parts of the IP that are delivered as GDS2. And there's various different components that are delivered as GDS2. And then you can assemble them into the topology of PHY that you want. We offer a range of different topologies. There's a lot of things that are possible here. The single row PHY is what most people think of when they think of a DDR PHY, but we certainly are able to produce other topologies like a double row PHY, which can be more compact on the shoreline basis, as well as an L-shaped PHY that can go around the corner of a chip and help to use some of the chip resources in the corner of the chip. So those are very, very flexible options to be able to choose the physical topology of your DDR PHY. And then the other option here, again, if you go to hard PHY option, the hard PHY options are where we're delivering a complete GDS2 of the entire PHY to you, and we will close all the PHY timing and deliver a hard PHY GDS2 top. Even using any of the previous floor plans, which can be done with a firm PHY, those can also be done with a hard PHY. So I want to spend a few moments here talking about GDDR6 because not a lot of people are really fully aware of what GDDR6 can do. We're finding a lot of applications outside of graphics where GDDR6 can be used. And it's definitely offers more bandwidth per pin than DDR5 or LPDDR5. It's at least twice as fast. It's also less expensive and simpler and has the traditional packaging technology, which gives it some differentiation from HBM. Right, so we see this application space for this. We see it very, very popular in the AI space where they have a particular need, especially in inference engines, to be able to have a lower capacity of memory, which is going to be lower cost, but still get a lot of bandwidth out of it. So I've drawn this chart here on the right here. You're probably looking at it by now and wondering what it means. So what I've tried to do is kind of put a matrix together, or a chart, the bandwidth obviously on the vertical axis, the capacity on the x-axis, and remember, more capacity costs more dollars in terms of the numbers of bits that you would provide. So as you add capacity moving to the right of the chart, there's definitely extra cost added. It's not strictly a dollar chart because of course the HBM memories are going to be more expensive than the other types. But this is just a relative thing. Like if you're considering a technology, as you add capacity, it adds dollars into the system. So the key thing to mention here about GDDR6 is that it fits into a particular niche in the solution space where you can achieve a relatively low capacity with just one die offering up to 512 gigabits per second. But really being able to get a lot of bandwidth out of it compared to the other memory types. And then you can also do the trick where, adding more channels, of course, will give you both more capacity as well as more bandwidth. And that's something certainly you'd see that on a graphics card that was using GDDR6. So that's a technology that's really been interesting for a lot of applications. From a memory perspective or a system perspective, it's quite familiar in terms of how it's built, again, giving 16 gigabits per second per pin and 2 independent data channels, giving a lot of flexibility about how the data is structured. Now, for Cadence's solution here for GDDR6, we've been putting a lot of work into this, and we really wanted our customers who are using GDDR6 to have a feeling like they're really using more like a DDR4 or DDR5 solution that they're more familiar with. So, our technical specs were to be able to achieve a very high bandwidth, but still being able to use an FR4 PCB with no special processing and achieve a good bit error rate. So we've been able to do that, and that's something that's relatively unique to the Cadence IP, to keep the bit error rate relatively low as part of the GDDR6 product. We definitely have architectural scalability to go much faster than 16 gigabits per second. Please ask us about that. And the power or the energy per bit is well managed. So we have a lot of test chip tape outs for this. We actually have 5 pieces of silicon, 5 different test chips in our lab with GDDR6 on them today. So we'd be happy to share those results with you. And this one is only delivered as hard PHY. So this one, basically you just reserve a space on your chip for the GDDR6 PHY, and you can drop it in and have very high reliability that this is going to work as intended. This is some of the press releases indicating some of the chips that we have silicon for in the GDDR6 space, and a picture of one of our test boards. So what I'd like to do here is kind of sum up the things that I've talked about today. It's a very, very short presentation, but I want to get across that Cadence has a complete solution available. It's a very broad portfolio of products, including DDR5, LPDDR5, GDDR6, and HBM technologies. Cadence is offering both the controllers and the PHYs for all of the technologies that we offer. And then as part of the available deliverables are things like TLM system models, the support for emulation and prototyping, the bring-up software that I mentioned earlier, and Cadence as a broadline provider of verification IP and EDA tools can provide all of the EDA tools necessary to build your chip, of course, as well. The IP is application optimized. We want to give you that flexibility that you can choose the topology of your circuits and also the relative capabilities. So we try to optimize feature selection and things like that, give you a lot of options in floor plans and bump map planning and those types of things. We offer the PHYs either as firm in some cases, or all of the PHYs are available as hard PHYs using the PHY hardening service. And then we also offer as expertise in the signal integrity, power integrity area. We offer those services and expertise to be able to help to close that as well. And then finally, just overall, Cadence's DDR IP expertise. We have silicon reports on more than 40 of our test chips. So we've done this a lot of times with a lot of customers. We've got a great product roadmap trying to hit the very highest speeds of the new memory technologies on some of the most advanced processes. And this is IP that's used in all kinds of applications all over the place. We're very happy to be able to offer it to you. So with that, I think that's the end of my presentation today. So again, thank you very much for listening. I really appreciate that you've made it this far in the presentation. And I will be joining later on today to participate in the question and answer session, where I'll be available to answer your questions. And then, of course, at any time, you can speak to your Cadence representative for things that I haven't talked about today or not able to talk about in a public forum. We'd certainly love to talk to you about those in private forum. So once again, my name is Marc Greenberg, and thank you again for listening to my presentation about Cadence DRAM interface IP. Thank you.